Alright, so we're going to start Unit G today. We haven't updated the board yet, but we'll get that updated here momentarily. You have a note packet for G that you picked up when you came in. You've got a new binder, cover sheet, whatever you want to call it, for Unit G as you came in. Unit G is going to be all about rates of change and slopes of lines and all that fun stuff. Okay? So today I got some good news and I got some bad news for today. Okay? What do you want first? Bad news? You got to think today. You're going to have to do a lot of thinking today. Okay? It's a lot of like I want to say abstract type stuff, but it's not 2 plus 2 today. Okay? It's thinking about what things mean and the meaning behind them. Okay? Good news is if we get through it, no home. Okay? Right? So if we can get through this thinking, this abstract type concept stuff, we can will not have any home. Right? Okay. So at the top of G.0, okay, which is kind of like the intro to Unit G. Okay? What? It says go. Yep, at the top of go. That's a good way of saying it. Okay? We've got 12 different things. Okay? I got the 12 right there up on the board. What can you tell me about all 12 of them? Give me a blanket statement for all 12. So there's something per something else, right? Okay, right? But not 12 cookies per dozen. Well, I suppose one dozen. Okay, all right. So what are we doing in all 12 of those? For what? Everything is per something else. So what are we doing? What does per mean? Like, what are we doing when we say the word, when we say 25 patients per one day? What are we doing there? Or what? No, we're not rounding. You start seeing. No. All right. Well, switch it around. Let's move it over here. Let's go to $13 per hour. What are we doing there? No? We'll come back. Let's come back to it. Wait out. It's not equaling something. No. All right? We'll come back to it. All right? So, let's go here and let's get what our definition of a rate of change, which is right in the middle of your paper. Okay? A rate of change is how one quantity changes in relation to another quantity. How one quantity changes in relation to another quantity. How one quantity changes in relation to another quantity. Now that we know what a rate of change is, let's go back. Are these rates of change? Is it one quantity, how it relates to another quantity? Is it how one thing relates to something else? Are all of those? Yeah, okay. So what really are those? What are we doing with those two things? We're what? We're not adding them. We're not doing any of that. We're not doing any adding. We're not doing any subtracting. Any dividing. What are we doing with those two things? We're what? Not converting them. We're comparing them. Yep. We're comparing two things. Okay? So what do these all have in common? They are a comparison. Oops, have to break this up. I got the wrong mark going on here. So all 12 of those are comparing two things. Okay? In the first one, let's go left to right, top to bottom. Okay? What are we comparing in this first one? Quarters to dollars, right? Second one, players to teams. Third one, ounces to quarts. Bottles to case, right? Oh, this one. Dollars to an hour, yep. You were one ahead. Miles per hour is that one. Okay, so miles to hours. Caffeine to cans of Monster. Oh, I don't drink this stuff, so I wouldn't know.
Is that what's under my bed?
A Monster under your bed?
I'm a little scared.
Well, they make a light for that. Patients per day, cookies per dozen, dollars per gallons, okay, and so on and so forth. Okay? All comparing two things. Okay? So, first example, this is just kind of off on the side for right now. If you don't want to write this down, you don't have to write this down. Okay? So first example, I might compare quarters to dollar, or to a dollar. How many quarters are in a dollar? There's 4 quarters in $1. So the comparison there would be 4 quarters per $1. Okay. Or we could write that in fraction form. Like that. With me? Yeah. What does that rate of change look like if instead of comparing quarters to dollars, we compared dimes to dollars? $10 dimes per $1? Yeah. Now, this is where this morning's class used their "I'm too tired to think" excuse. Yeah? Let's talk blue versus green. Are they the same? They're both rates of change. Are they the same? Why not? Because they're not what? Not the same amount. They're not the same like things, right? They're different things. Okay? So different comparisons are going to have different rates of change because you're comparing two different things. If we go back, for you, if you just look back up top, and all of those rates of change are different because they're all comparing different things. Okay? Now, you may be saying to yourself, so does that mean that we should all, if we're working a job, we should all get paid the same? Because your wage is a rate of change. Okay? If you make $10 an hour, for every hour you work, you're going to make $10 more. Okay? But your job might be different than somebody else's job. So therefore, that's why there's different rates of change for wages and stuff like that. Okay? Let's do these next two. Pennies to dollars. What would the rate of change be for pennies to dollars? What? 100 pennies to $1 for $1? 100 pennies to is another way of saying per. Okay, so you could say the word to there instead of per. Okay. All right. What about pennies to quarters? 25 what? 25 quarters to a penny? Because does it make a difference? If each penny was worth 25 quarters, that'd be pretty cool. Right, exactly. Okay? Okay? So it's 25 pennies to 1 quarter. Now, one good thing that came out of this morning's class is for that one, they came up with 50 pennies per 2 quarters. Are those two rates of change the same? They're not the same, but are they? Why? Okay, can you clean it up a little bit for me? Are they equal? In that last line, are they equal? You sure?
No.
You sure?
No.
You're not sure, or?
I'm not sure.
Okay, well, so you agree that 25 pennies is 1 quarter?
Yeah.
Okay, so how many, if I had 2 quarters, how many pennies could I get? 50. So would 50 pennies per 2 quarters be the same rate of change? Yeah. Okay. The only difference between this one and this black one is that the black one is not reduced. Okay. Okay. But those two are the same rates of change. But orange to purple, orange compared to purple, compared to blue, compared to green, those are all different rates of change because we're at different comparisons. Okay? Alright? So if I'm going with the 4 quarters per $1, okay? So if I'm filling out a T-chart, so now there is a T-chart there on the side there for you, okay? So my dollars, okay? My dollars would go in this one because it's the per. quarters would be in this one. If you think about it, the X value that we would have graphed last week, okay, that's going to be the one that's on that comes after the per. That's on the denominator. What? Okay. So if I have $1, how many quarters do I have? 1, and I got 4, right? If I have $2, how many quarters do I have? 8. If I have $7, oh, I tricked it up there. Got you. Oh, if I got $7, how many quarters would I have? How many? 28. Now, we'll keep it mixed up. If I have $1.5, if I go, so that's $1.50, right? How many quarters? 6 quarters. Okay. If I have X dollars, how many quarters would I have? No. What? What are we doing with the X and the 4? We're add, subtract, multiply, or divide. Multiply. So can we go 4x then instead? Yeah. In this particular rate of change. Okay. What I'd like you to, so today our goal is to see rates of change for everywhere. So it's something per something. And we could write that as a fraction, or we could write it with the word per, or we could compare it with the word to, okay? All those different things. Okay? All right? What I would like you to do now is find a spot. So we said on the whiteboard, but we're just going to go right down here in the lower left-hand corner of your paper. And I want you to come up with your own rate of change. It doesn't have to be true, okay? Just make up a rate of change so where you're comparing two things, okay? I'll use miles per hour, okay? So 1,601 miles it takes to drive to my parents' house in Florida. It takes 22 and a half hours. 1,601 miles per 22.5 hours. Rate of change. Come up with one right now. Everybody got one? Got a rate of change? Okay. What was your rate of change? 24 Gatorades per pack. Okay. Love it? Yeah. That's a good one. I just wanted one. Because now what we're going to do is with your own individual rate of change, what I want you to do is I want you to, so and on yours, Wyatt, you would say your pack would be here on this side, and you would have Gatorades on the other side, right? And you said for one pack, there's 24. I want you to come up with 2 more entries into your table that make your rate of change be true. Okay? So 2 more. Find 2 more entries that make your rate of change be true. Anybody know why it's called Gatorade? Anybody know the history behind it? It was developed by.
I think I know.
Yeah.
Is there like a gator that can escape?
Nope. Nope. It was developed by a trainer for the University of Florida's football team. Because they were cramping up in the Florida heat, and the University of Florida's nickname is the Gators. So they developed it. It was actually two guys, and they said it helped the Gators, so they called it Gatorade. And then PepsiCo bought them out like 20 years ago or so, and went to town. Yeah. So you should have 2 more lines. So for instance, Wyatt, on yours, you would have maybe a 2 and a 48. And then let's get crazy. Let's go 1.75. I know you probably don't have 1.75, but that would then be 18. So we would subtract 642. Okay? Awesome sauce. Okay? Today, all we wanted to do was get you thinking about rates of change, get you a little bit of introduction to them. Okay? Okay? No,